All right, here we are moving into talking about the addition reactions of alkenes. And so here's the first addition reaction that invariably every student will experience, the addition of HBr to an alkene. This is where we're going to introduce terms like Markovnikov addition, and we're going to really start to think about the first mechanisms of reactions. We did a little bit of mechanisms in the SN2, SN1, E2, E1 chapter. We're going to continue on with that and start to really introduce and kind of hammer in on synthesis. And so this is that first problem. So you do have to just sort of know these reactions, and there are several different ways to know how to predict the products and what reagents that you need, but ultimately you just have to practice and you have to be familiar with them. So what's the addition reaction of HBr? One thing you need to remember is that it's going to add H and Br across the double bond. And so you're going to have a product that looks like this. Now, where did the H add? Well, of course, this used to have 2 hydrogens. Now it has 3. And so that's where the H and the Br added. Now, there is a regioselective, regiochemical consideration in this reaction, in that the Br adds at a particular location. We say that the addition is Markovnikov, which means that the bromine, there's going to be some group that we're going to be referring to when we say Markovnikov. In this case, it's the bromine. The bromine adds to the more substituted side of the alkene. And now it's also asking us to think about the mechanism, and that mechanism will explain that regiochemical outcome. So we're going to do a proton transfer, and the Br is going to pop off and become bromide. That's going to form a carbocation intermediate. Now, this is the thing that explains the regioselective outcome of the reaction. I could form a carbocation here, having the hydrogen add at the more substituted location. The other option is that the cation could have added at this location, the more substituted location. One of those is more energetically favorable. And clearly, if you remember from chapter 6, the chapter on thermodynamics and equilibrium, you remember that a tertiary carbocation is more stable than a primary carbocation. And so that's the carbocation that's going to form, and that's why the bromide then subsequently attacks the more substituted location. And so it's a pretty straightforward, simple mechanism. You've definitely looked at harder mechanisms in the past, but you really do need to get your head around the fact that you're going to have to learn mechanisms. Okay.